Hello everybody, I'm Vallati and I'm going to talk about this work about a quality framework for automated planning knowledge models. Now, one of the main assumptions of domain-independent planning is that there is a logical separation between the planning engine, which is the software or the system which is solving a specific problem, and the domain model, which incorporates and encodes the knowledge about the application domain and describes what can be done, so what the planning engine can take into account for solving a problem, and of course the specific problem to be solved. And this model and these knowledge models present the biggest validation and verification challenge to the planning and scheduling community. Questions like how should domain models be formulated, debugged, and judged to be fit for the purpose? How can we determine the quality of a model and to some extent the quality of the language in which it is written, and which is leading to the question of how can we compare different models and how can we decide among two models which are equivalent under some form, decide the best one to pick up. And that's why we are focusing on this quality of the models in order to find solutions to the questions and support then the work of knowledge engineers. In a recent work presented at ICAART in 2017, a number of properties about domain models has been introduced, and they are described in here. So we have accuracy, consistency, operationality, completeness, and adequacy. And notably, all these notions of models relates only, well, either to the specific knowledge model or to the language. Operationality has some relationship with the planning engines and the overall requirements. But to some extent, the take-home message from that previous work is that most of the quality properties are focused only on the model. And we left behind the idea of a single overall quality notion because that's extremely hard and basically impossible to achieve for this sort of models at least. And so we moved, as you can see in here, to a notion of different, multifaceted notion of qualities where each property takes into account some different aspects of what quality can mean for a model. And but that work that we presented in 2017 is quite limited in the sense that it focuses on the model, but it doesn't take into account the processes or all the other stakeholders that play a role, and maybe a significant role, in the creation of a model and in the update of a model. And that is exactly the point of this work. In order to identify all the stakeholders, all the different components and all the processes, we relied on a framework. And a framework which has been introduced quite a few years ago actually, for evaluating the quality of conceptual models. Now, conceptual models and planning models, they share some properties and some characteristics, but there are also some major differences, and these are discussed a bit in here, but of course you can find more details into the paper. And what we have done is taking one of these framework, the SQL framework, which is probably one of the most famous, if not the most famous one, and specialized it on planning. And here I'm just pointing out what are the main differences between general conceptual models and planning models. So in planning, the modeling has a clear and well-defined goal, which is allowing to generate solution plans. So we want to have models which are not only storing knowledge, but which are useful to be reasoned upon to find solution to some specific problems. And this is the proposed framework that we built by specializing and modifying the SQL framework. And you can see in here the different components, so the different notions which are in place, and the processes. So the processes are the edges, while the components are the different squares. And so we have initially the domain, which is the application domain. So it's not a model, but it's what is known about the domain where planning will be applied. And there is then an interpretation which is done by stakeholders. So if we can think about an agent which can be a knowledge engineer that want to create a knowledge model of a domain, this knowledge model, which is done by that specific person, is based on her own interpretation of a domain and of the requirements. And this interpretation is also relying on the current knowledge of a specific agent. Current knowledge that can be domain specific, something about a specific domain, or can also be expertise from the encoding of models in the past. And based on this interpretation, then the agent is creating a model which comes under the form of a model externalization. So it's not just a mental model, but it's something which is written down in a specific language. And this model can then be used by a planning engine or an automated system to create a solution. And this solution, since we are speaking about the application of planning to a real world, has then some impact on the specific domain that we're thinking about. And this is closing the overall loop. And so these are the components, and to some extent some of the stakeholders. So we have an agent which is creating the model. We have a planning engine that needs to be able to read the model and understand the language, and then there is someone which is activating the solutions in the domain, at least. And on top of that, the different arcs, the arrows, are the processes. So the articulation process, which goes from the domain to a model externalization via the interpretation, is the process that is used, that is followed by an agent in order to create a model based on its own interpretation and on the current knowledge. The reflection, which is this process here, stands for the impact that the language has on the form and on the externalization of the model, as well as on the planning engine. So we can have the language is affecting the planning engine in the sense that some engines are supporting different languages. So if you choose a specific language, you may not be able to use a specific engine. And also the language is affecting the way in which you are representing the model. So that is having an impact on the way in which the engine is reasoning upon it. Execution, which goes from the model externalization via the engine to the solution, is the generation of solution plans. And that should be quite easy. And then there is the activation, which is the process of applying the solution in the real world, which can change in some way the domain specification or the domain at all. So if you're thinking about a traditional application of computer science to a real world, when you start applying and when you start seeing the results of what has been applied, you can see that the domain is evolving and new requirements may be generated or new functionalities may be asked. That's exactly the sort of process that we're looking at activation. And then there are two self-loops, which are the process of changes and the process of evolution. So the changes incorporates all the changes to the specification that are due to environmental variables, so things which are not triggered by the activation, but which are changes in the domain by itself for some exogenous events or exogenous reasons. And then the evolution, which is the focus of the evolution of a model M. And this is just different versions or different modifications of the same model externalization. And that can be triggered, for instance, by a change in the agent or by a change in the knowledge of the agent, which is becoming more expert, or a change in the interpretation, or something which is related to the language or the planning engine. And now that we have a framework and where we specify the stakeholders, the components, and the processes, we can start building some notions of qualities via quality levels. So quality levels have been defined in the semiotic ladder from 1996, and what we're doing here is modifying the original quality levels in order to specializing them for the planning domain. And so the quality levels, this is a ladder which is starting from the lower possible level up to some more abstract and more interesting levels of qualities. The higher you go, the highest must be the quality of the lower levels in order to allow you to start thinking about the above levels and to start improving them. So, for instance, the physical quality just means, since we are speaking about semiotic and we're speaking about models externalization, the physical quality corresponds to the fact that there is somewhere a model which can be externalized, so can be written down, and can be internalized, so you can read it. So the physical quality just focus on elements about the way in which you are writing down the model, basically, to make sure that it is available and it is readable. And then you start building up on top of that to the semantic quality, which aims at the goals, where goals here are properties that you would like to see in your models, like accuracy and completeness. So you want a model for an application domain to be accurate and to be as complete as possible. And then you move to the pragmatic quality, which is about the activation of model externalization. Syntactic quality, which is the correctness of a model with regards to a language. This syntactic quality allows them to start thinking in terms of the operational quality. So if you have something which is syntactically correct, which is accurate, which is complete, and which is readable, then you can think in terms of operationality and operational quality. So the ability to use planning engine to reason upon the model and to solve it, and to close the loop that we have seen in the framework. So these quality levels, as you can see, they are not only focused on the model, but they are in some sense orthogonal to the model and covers all the framework, so differently from the work from 2017 that we have seen before. And they also have goals, so you can exactly know what is required in order to make sure that that specific quality is achieved, in a sense. And this is quite important in order to optimize the processes and to make sure that the overall knowledge engineering framework and process is sound. So what we have done in this work is introduce a framework for characterizing the quality of planning models, building on top of existing work in the conceptual modeling area. One thing that I didn't show in this presentation, but it's present in the paper and it's actually a significant contribution of the work, is that we applied our framework and the quality notions in order to check how existing knowledge engineering tools are supporting the knowledge engineering process. And we have found out that there is a lack of support, but of course you can find more about that in the paper. And the main benefits of a framework include we can replace ad hoc notions of quality with a connected, composite and overarching notion, which is covering all the aspects, processes and stakeholders which are involved in the knowledge engineering of a model. It provides a clarifying terminology, so we can have a sort of vocabulary. It is shared and can be used by everyone for speaking about quality for models. And we provide a ground for relating existing tool with a process. So this is done theoretically by the framework itself, but it's also done practically, in a sense, in the paper. So you can find additional information in there. And for the future work, we are investigating how this introduced framework can be exploited in practice. So beside comparing tools, if we can use it for designing tools from scratches and build on top of it, and also providing some measures for dealing with identified qualities and goals of the qualities. So try to provide a way to understand if the different qualities has been met before moving to the next one. And of course something which can specify a bit more the processes, which are though very language and very application dependent, so that can be a bit hard. And that's all from me. Thank you very much for your attention, and of course you can find additional information in the paper, but I'm available for answering questions.